Well, hello everyone, and welcome to Amazon EC2 High Memory Portfolio for SAP HANA session. First of all, thank you for being here on a Thursday late afternoon session. I know it's kind of commitment to come all this way, this late, right before the Amazon replay. So we'll try to make this session worth for you. I am Vikas. I am part of EC2 Product Management Group, and joining me today is Arnie, my colleague. He's the lead architect for SAP solutions on AWS. And we are pleased to also have with us from SAP, Davis Smith, who is their SAP Solutions Architect for AWS. So between us, we are hopefully going to share quite a bit today in the next 40 to 50 minutes. Actually, before I get started, can I have a show of hand on how many of you have used high memory instances? Oh, that's great. I mean, very pleased to see that. Since I did not see a few of the hands go up, a very quick intro into high memory instance. This is a purpose-built instance to run large-size SAP HANA workload. So think about SAP workload or SAP HANA workload that need more than 6 terabytes of memory. So that's where this instance is focused on. So we'll quickly start with sharing some of the feedback that we get from customers on why they moved their on-prem SAP HANA workload onto AWS EC2. We'll introduce the net new addition to our high memory portfolio. Then I'll turn it over to my colleague, Arnie here. He is going to walk us through the technical underpinnings of EC2 high memory instances that deliver the benefits to the SAP HANA workload. And then we are going to take a closer look into why SAP uses EC2 high memory instances to power their internal workloads as well as SAP RISE customers' workload. And then I'm going to be back here to give you some pointers as to how to get started on high memory instance. With that, without further ado, let me get started. So we announced support for SAP HANA on cloud in 2012. And ever since, we have been constantly innovating for our customers as their compute and memory requirements have evolved. Many a times being the first in the cloud to do that. We announced the high memory instance in 2018. That was the first generation. And end of 2023, that is reInvent last year, we announced the arrival of the latest high memory instance, U7i. That runs on 4-socket and 8-socket platforms and offers anywhere between 6 terabyte to 32 terabyte of memory. But apparently, that wasn't good enough for some of our customers. They wanted more compute. And this is where, in this reInvent, we have announced a net new addition to our high memory portfolio, U7INH instance. This we have built in collaboration with HPE, running on 16-socket platform that delivers 1,920 vCPUs with 32 terabyte of memory. We are going to take a very close look at this instance just in a bit. So over the years, ever since we announced the support for SAP HANA in AWS Cloud, we are pleased to share with you we have thousands of customers that are running their HANA workload in AWS. We are very humbled and pleased to have their trust in us. So let me do a quick recap on some of the things that we hear from our customers as to why they moved their SAP HANA workload from on-prem to EC2 high memory instances. First and foremost, the feedback that we hear is, compared to on-prem, on EC2 side, they see or they experience a significant reduction in the procurement time, the install time, and the deployment time of the infrastructure to power SAP HANA workload. And this reduction is primarily because on EC2, the instantiation or the launching of infrastructure is all about executing few command lines. In this example, this customer is going to be launching a high memory instance of 18 terabyte capacity with this command line. It's as simple as that. The second thing that we hear is the flexibility and the benefit that comes with it. So typically on-prem deployment, you would always invest in very expensive over-provisioning of the hardware. And the reason you over-provision is you do not want to go into the upgrade cycle very quickly because upgrades are quite complex, they take time, and they're expensive. So if we eliminated the pain of the upgrade, the customers could then start with whatever the size they need at that point in time, and then upgrade when they need to. That is exactly what we do on EC2 high memory instance. You start with the size that you need today, and upgrade to the instance size that you need in future when you need it. The act of upgrading an instance size is all about you stop your instance, you reconfigure the instance, and then start it. So in this example, the customer on the left is now following all these steps to upgrade from 18 terabyte of instance that he started, and now he moves to 32 terabyte of the new generation high memory instance. So no more cycle of procuring, installing, deploying, and all those things. We have eliminated all those complexity, and they love it. The third is, it's a very important pillar. So as we all know, SAP HANA is a mission-critical application, and it demands very high level of availability. But the failures do happen, and they come in different forms and shape. Software failure, hardware failure, site failure, regional failure, and what have you. So setting up a resilient architecture on-prem to handle those kind of failures is very complex, again, time-consuming and very expensive. Coming to AWS, we eliminate these complexities for them, and we deliver them the SLA that they need without, again, these complexities. And the reason we are able to do that is threefold. First, we provide them with variety of availability zones and regions across the world where they can set up the HA topology that matches their need. If the failures do happen, as I said earlier, failures will happen. In those cases, leveraging our deep expertise in resolving the hardware issues, the software issues, through our mature process, we get to expedited resolution. And finally, since we have a close collaboration with SAP, when the problems arise, we look at the stack in totality, the software and hardware, to get to the resolution quickly rather than investigating things in isolation. And finally, in the performance, we are known for delivering the performance with all the benefits of virtualization. So there is no compromise. The EC2 instances give you all the benefits of virtualization, like quick reboot, quick upgrade, quick stop. Those are all the hallmarks of virtualized instances. But at the same time, we deliver the performance similar to the bare metal and meet the stringent requirements of SAP benchmarks to get their certification. And this is all because of one key thing, Nitro architecture. And Arne will walk us through the technical underpinnings of Nitro architecture, but at a very high level, because of this Nitro architecture, we are not able to only give you performance, but also make available entire host compute and memory for your SAP HANA workload. It's all available to you. The second thing that it does on top of that is we are able to give you the highest block storage bandwidth and network bandwidth in cloud for this class of appliance. The EC2 U7i new instance that we announced last year and made it generally available is U7i. This is powered by Intel's latest 4th generation Xeon scalable processor. It supports 6 terabyte to 32 terabyte of memory. And if you use U-1, you'll be pleasantly surprised with the performance that you get. It has 135% more compute and 2.5x more storage bandwidth to enable faster snapshot, faster backup, faster hydration time, and so forth. But as I explained earlier, this wasn't good enough for some customers. So we're going to take a close look at the new instance that we announced at this reInvent. So this is our latest addition to high memory portfolio. This instance is powered by HPE 16-socket platform. It's fully Nitro integrated, and that's the key thing. So you get best of the resiliency of HPE prior generation Superdome instance, coupled with all the goodness that Nitro delivers, the security, the manageability experience. It would feel exactly like any EC2 instance that you have experienced so far. With 1920 vCPUs, 32 terabyte memory, 160 gig storage bandwidth, 200 gig network bandwidth, we pack in ample compute power and the back-end bandwidth so that you have end-to-end no bottleneck. One important thing is this is the only 32 terabyte virtualized instance in cloud that has standard SAP certification for both OLAP and OLTP workload. No one has that. With that, I want to just highlight one important thing. These instances are premium instances. So we wanted to give some choices to our customers, especially as you go to the highest or the top tier instance sizes. Therefore, we have enabled two choices for 32 terabyte instances. One comes with 8 socket, other comes with 16 socket. And the reason we enabled the 8 socket is with 896 vCPUs, you have enough power to meet compute requirements of several of your workloads that demand 32 terabyte of capacity. So if your compute requirements could be met with 896 vCPUs, just go ahead and use this. But should you need more compute, because that's what the estimation says, then you have 16 socket. And remember, you can always start with 8 socket, and as I explained, follow those 3 steps and upgrade to the 16 socket. So, and we are the only cloud vendors to, very pleased to say that offers this. With this, I'm going to turn it over to my colleague Arnie here to walk us through the technical details of the EC2 high memory instances. Arnie?
Hey, my name is Arne. I'm the tech lead for SAP as a customer at AWS. And I'm going to walk you through some more technical details, specifically for SAP HANA workloads and how HANA benefits from the EC2 high memory instances. Let's first have a look at the entire portfolio which is certified for HANA workloads on AWS. SAP differentiates the certification between scale up, where everything on the HANA instance runs on a single EC2 instance, and scale out, where you're using multiple instances for your HANA workload. And also between OLAP for analytical workloads like BW and OLTP for transactional workloads like S/4HANA. Let's first have a look at the left-hand side on the scale up, where everything runs on a single instance. So certifications start with 256 gigabyte all the way up to 32 terabyte now. With that, we give you the option to right size and select the right instance according to your needs, and also to scale in appropriate chunks when you have more data stored in memory. With the new introduction of the U7i Vikas just mentioned, we give you also the options to upgrade your existing U-1 based on Cascade Lake CPUs, to upgrade these to a more performant Sapphire Rapids-based U7i instance. So if you need more performance on the compute side, you can change and upgrade your hardware by switching to these new generations. Also new, with that certification of the U7i 24 terabyte, is the certification for OLAP on a single node. Previously, if you want to run your BW system beyond 24 terabyte or with 24 terabyte, you needed to scale out. With the U7i 24 terabyte, you can stay on a single node before you need to go scale out. Looking at the scale out in general, first for OLAP for BW workloads, here we offer you very small nodes. So you start with 1 terabyte, 1.5, 2, 3, 4, up to 16 terabytes. And you have the option to scale either up to 8 nodes per cluster or even 60 nodes per cluster. So this gives you the scale, and either you can scale up to a very small instance sizes or up to 192 terabytes. Selecting the instance size for BW scale-out is crucial, because usually it's a trade-off decision between less nodes in your scale-out configuration or smaller node sizes to increase if you add a node to your cluster. For transactional workloads, we start with bigger nodes. We start with 6 terabyte per single node, and then always 4 nodes as a maximum in a scale-out configuration. Because here, S/4HANA does not benefit from having distributed tables across multiple nodes. So usually you try to put as many nodes on or as many tables on the instance, and you're trying to avoid to split tables across multiple nodes because of latency and performance. Here, the biggest size is the 4 times 24 terabyte, which is certified, and we also plan to certify the recently announced 32 terabytes. All this is possible with Nitro, as Vikas mentioned. So integrating new hardware, and this time, the first time with HP, external hardware as well, is possible for us through the Nitro system. The Nitro system is a combination of a dedicated hardware and our lightweight hypervisor, which gives us the opportunity to innovate faster and to enhance security on the platform. The Nitro system consists mainly of three main parts. The Nitro card, which is dedicated hardware component that operates independently of the system mainboard that runs all your workloads. The Nitro card is a family of cards, so you have multiple cards actually in the system. So one is for EBS for networking, or VPC for EBS for storage, and VPC for networking, for example. Basically, all components that interact with the outside world of the EC2 service beyond the system mainboard runs on self-contained hardware, which is physically separated from the system mainboard. The second component is the Nitro chip, which is integrated into the motherboard with a locked-down security model, which prohibits all administrative access, even those of Amazon employees. The third component is the Nitro hypervisor, which is our lightweight hypervisor. The Nitro system is also the reason why the full memory and CPU performance is available for your customer workload. It provides bare metal capabilities that eliminates virtualization overhead. This is important for HANA because you want to leverage the full memory and all CPUs for your in-memory database. The Nitro system manages network, storage, and security. And I want to have a little bit of a closer look into network and security, starting with network. The Nitro cards offload the VPC data plane from the hypervisor that enables ENI attachments, security groups, flow logs, routing, and much more. With the Nitro card, there is a dedicated bandwidth assigned for the network traffic, which separates the traffic from the storage. So you are not competing in writing to the storage and having network traffic to your system. This leads to a high throughput for backup and recoveries, while you can also write to your storage. And also, especially for HANA scale-out, for the internode communication, the high throughput to communicate between the nodes is crucial. For security, the Nitro system hardware automatically encrypts traffic in transit between two EC2 instances with a 256-bit encryption. And the best thing, this all comes without impact on network performance. So there is no trade-off between security and performance. Another new thing and innovation we can add is the ENA Express, which is now able to attach to the U7i instances. ENA Express is powered by AWS Scalable Reliable Datagram, or SRD technology, which improves network performance in two key ways. One, it is a higher single flow bandwidth, and two, it lowers the tail latency for network traffic between two EC2 instances. And especially the HANA scale-out benefits because it is very latency sensitive and requires high throughput between the nodes. The SRD protocol is a proprietary protocol and improves the inter-node communication and gives advantage through congestion control, multipathing, package reordering, and much more directly on the Nitro card. The ENA Express increases the maximum single flow bandwidth from 5 gigabits per second up to 25 gigabits per second, and can also improve the network performance and tail latency by 85%. And the best thing, all this is transparent for HANA. So as soon as you configure two EC2 instances with ENA Express, they communicate through the SRD protocol. You do not have to configure anything. And HANA automatically leverages then the higher throughput and the lower latency. Previously, without the ENA Express, you had to configure cluster placement group. So logical grouping of instances to achieve low latency. Now with ENA Express, this is no longer mandatory. So that gives you more flexibility during the deployments. Vikas showed you some numbers and some specifications, and I want to bring this into context for SAP and especially the subs value. Quick show of hands, who is familiar with the subs value in the room? Okay, some of you are, so let me quickly explain it for the rest. The subs value is a SAP application performance standard. So it is a measurement of hardware-independent performance in the context of SAP. It measures sales and distribution benchmarks where 100 subs is defined as 2,000 fully business processed order line items per hour. And as you can see, the previous generation of the U-1 instances already delivered around 500,000 subs. With the newest generation, we achieve over 1 million subs. And if you look at the middle graph, we compared the U-18 terabyte on Cascade Lake versus the U7i 16 terabyte based on Sapphire Rapids. And there is an increase of 146% of subs between these instances. So the U7i 16 terabyte delivers 15.2 million more order line items per hour compared to these two instances. This is, yeah, pretty amazing. Looking at the storage options for these high memory instances, because even memory or HANA is an in-memory database, you need a reliable storage, which is also performant, that gives you the benefits of your instance. We offer AWS Elastic Block Storage or Amazon EBS, which you can attach to your instance in different flavors and types. So IO2, Block Express, GP3, and so on. And you can attach up to 128 volumes to a single instance. And you can also change the different volume types online without downtime. So you, for example, can switch from GP3 to IO2 Block Express. The second option is Amazon FSx for NetApp ONTAP, which provides you the NetApp features in the cloud, which you might know from your on-premise experience. So you can use, for example, SnapMirror to replicate your data from one location to another, or FlexClone for system refreshes. For backup purposes, we provide Amazon S3 as an object store, which is designed with a durability of 11 nines to store your backups in multiple devices distributed across a minimum of 3 availability zones. So the backup is stored in the most reliable fashion here. You can also use the snapshot capabilities of the storage option. So you can use EBS snapshots or the FSx snapshot capabilities as well. I want to drill down a little bit more into the EBS configuration. So the instances, first of all, benefit from the dedicated network performance which is enabled through the Nitro cards for the EBS. So they don't, again, compete versus the network traffic because there is a dedicated channel for your network traffic. With the EBS, we recommend to use multiple volumes for your HANA workload. And depending on your HANA instance size, we give you the recommendation to meet the SAP KPIs and to achieve good performance. In a scale-out configuration, each HANA node has its own EBS volumes attached, following the shared nothing principle. On FSx NetApp ONTAP, even the root volume remains on EBS, but the rest can be configured on FSx ONTAP. So HANA shared and HANA user sub can share one volume, but HANA data and log must have their own FSx NetApp ONTAP volumes. The HANA data and log also are only supported in a single availability zone, so it cannot be stretched across multi-ACs. However, you can use SnapMirror to replicate the data from availability zone 1 to 2. We recommend to use separate storage virtual machines for the HANA data and log to ensure that the I/O path traffic flows through different IP and TCP sessions. This is purely because of performance reasons. The FSx NetApp ONTAP takes benefits of the 200 gigabits per second dedicated network bandwidth. And one unique feature using that storage type is that you can enable the HANA host auto failover. So that means you have an active instance configured in your scale-out cluster, which sits there, and as soon as one node fails, it automatically remounts the storage and takes over the operation. So this is to reduce the RTO in terms of a system failure of your HANA scale-out cluster. We also did some more benchmarks, which I want to show you here. So here is another benchmark using the hardware and cloud measurement tools from SAP. This is a tool which simulates writing data blocks into the storage. And you see different block sizes according to what HANA is usually writing into the storage. And we differentiate between HANA data volumes and HANA log volumes. And as you can see, we are not only meeting the bar here on the KPIs, but in this example, the read performance, we overachieve the KPIs multiple times. Let's have a look at the write performance as well. So again, you see data and log volumes with the different block sizes, and the measurement is in megabytes per second. And on the top, we are writing a 16 megabyte block in an overwrite fashion into the storage. The write performance measurement here is distributed or separated between initial write and overwrite, because sometimes you are simply writing on top of an existing block. The KPI is 250 megabytes per second. In our test, we achieve more than 10 gigabytes per second. So we are, again, not just meeting here the bar, but we are really going over multiple times the value to achieve good performance for your workloads. So why does it matter, right? Imagine you're going to start up your HANA database and you need to load all the data from storage into memory. The faster that happens, the faster you can experience the performance of your actual in-memory database. Because only when you're not writing blocks from storage, but only from memory, you experience the full performance. In that example, we were writing 5 terabytes of data into storage and then had a cold start. So meaning we are loading that 5 terabytes from storage into memory. And we benchmark the different EBS storage volumes. So as you can see, we compare GP2 versus GP3, IO1 versus IO2 block express. The load of the HANA database with IO2 block express only is around 11 minutes to load 5 terabytes of data. And this is this is an improved throughput performance by 300% over IO2. Same is for GP3 versus GP2. The throughput increases by 300% versus these two. And this is why you can load your data from storage much faster. Looking into the configuration, we also recommend to use either GP3 or IO2 block express for your high memory workloads. Coming to a next topic, which is backup, right? Usually, not many people are interested in backups until you need them. Then suddenly backups become super important, and it's crucial to have them reliable, fast, and with a high frequency done. That's why we've developed the AWS backend for SAP HANA. With that, you can stream your HANA database backup into S3 directly without staging the data somewhere else in between. That also uses the benefit of the dedicated network card, so up to 200 gigabits per second network throughput, while writing to S3. S3 in the background simply scales, so you don't need to worry about this. That also applies for the HANA scale-out, because here every node can write in parallel to S3. So as soon as you add another node to your scale-out configuration, your backup time does not increase linearly because you're writing in parallel. We combined this recently with AWS Backup, so you can schedule and do the scheduling and monitoring through AWS Backup while also using Amazon Backend for HANA database. So how to get to these instances? Vikas touched a little bit on how to do the instance resize, and I want to explain this in a little bit more detail. So I want to walk you through an instance resize. In this example, let's imagine we are on a 24 terabyte on the previous U-24 terabyte instance, and we need more memory, but also more performance. So how to get there? Actually, it starts, you need to stop your SAP application and the HANA database, and then you stop the instance. With a single API call or click in the console, you change the instance type, and then you start up your new instance configuration, in this case on the U7IN 32 terabyte, and then you start your application as well. Once the HANA database is loaded, you are operating on the new instance type. All the storage moves automatically. So you don't need to worry about how do I get my storage attached to this new instance type. And all the metadata and the configuration, for example, of the IP addresses or security groups remain the same. So you just need to have 2 API calls, stop the instance, resize, and start it again to get there. With that, you can right-size your instances faster, scale up, do hardware refreshes much faster than before. Now I want to run through the similar procedure, but focusing on capacity. I recommend to use on-demand capacity reservations, or ODCR, for your critical workloads, and especially for the high memory instances. ODCRs allows you to reserve capacity for your EC2 instances in a specific availability zone for any duration. This provides access to EC2 capacity as long as you need it, whenever you need it. When you create a capacity reservation, you define the availability zone, the number of instances, and the instance attributes like which instance type, the tenancy, and the platform, for example. In our example here, we run a 24 terabyte instance again. So again, the U-24 terabytes, and we want to change that. For that, we have an on-demand capacity reservation already created to have capacity reserved. And we also have compute saving plans mapped against our EC2 instance. So if we create that on-demand capacity reservations, there are actually no additional costs while the instance is running, because the capacity reservation also matches against the savings of saving plans or regional reserved instances. So we do this automatically in the backend if you have this. When you stop your instance, you still have the capacity reservation, and you're getting charged in an on-demand fashion as long as the instance is in status stopped. But you reserve the capacity, so as soon as you start the instance up again, you have capacity in place and you can start up your instance. Now, if you want to change the instance size, you create a new on-demand capacity reservation for your target instance size. As soon as this is successful, you can delete the old one. And then you do the instance size resize, which I explained before with the stop and start procedure. And then you are on your new instance size, having a new instance capacity reservation in place. Last week, we announced even an additional feature for capacity reservation, which allows you to reserve capacity in a future date. So you can now reserve capacity up to 120 days in advance, and you only pay for these starting with the provisioning of the capacity. This gives you the flexibility by planning the projects and reserve capacity when you need it and as soon as you need it. With that, I want to hand over to Dave to talk about more details how SAP is using the high memory instances for their workloads.
Thanks, Ollie. Good afternoon, everyone. My name is Dave Smith. I'm AWS Lead Architect for the Rise with SAP offering. And today I just wanted to kind of build a little bit upon what my colleagues from AWS have explained and how we use the high memory infrastructure. Before I do, though, I think background's important. So here we have Christian Klein and Matt Garman, our CEOs, on stage at Sapphire this summer in Orlando. It's probably worth pointing out that AWS was the first hyperscaler that SAP partnered with, and during this time we've released numerous joint products, co-engineering. Most relevant to this session, though, and a little bit which was mentioned before, was around the newer high memory infrastructure which came in over the last years. It was X1 in 2016, X1E up to 4 terabytes, and then 2018, the first U series. Now, of course, we talk about X2I, X2IE, and now U7I in its different families. So today, AWS infrastructure is used to power numerous offerings, as I mentioned, such as Rise with SAP, S4 HANA Cloud, Concur, and Signavio. So SAP's commitment to utilizing AWS extends to some of our most exciting current and future offerings. You will have heard about Grow with SAP. This was announced during reInvent this week, running on, more specifically, the AWS Marketplace, and Joule, SAP's AI system, which is integrated with AWS Bedrock. We've also announced that we will use AWS Graviton for numerous offerings, such as BTP, DataSphere, Analytics Cloud, and Cloud ALM. So today we offer ERP now in 2 flavors. Grow with SAP is our SaaS offering. It's for scale-ups, subsidiaries, and customers who are new to SAP. And we now have Rise with SAP, which is the vehicle that helps our existing customer base transform to our cloud offerings by supporting the transition of ECC to our flagship S4 HANA. So to expand on what we do in Rise with SAP, so today our footprint is in 33 AWS regions, which is the majority, including both in AWS China. We have several tens of thousands of instances, thousands of X instances, and hundreds of U instances. So touching a little bit about what we need from AWS, I broke it down into these sections here. Talk about scale, rapid deployment. We are pushing customers, trying to get them into Rise, and we need to be able to support a deployment growth and fill that pipeline. Reliability. Customers literally run their entire businesses on SAP, and so by extension, in Rise with SAP on AWS, then we need to have absolutely the best reliability. Performance. Customers, they're never the same. Big deviations in how they use the systems and the performance required. Also, don't forget things like seasonality. This comes into play as well. And flexibility. Customers regularly increase the size, and we and AWS accommodate that. So just to touch a little bit on deployment models, highly simplified, of course, and this is just the 3 main ones. There are variations on a theme. So this is just a single AZ. It's a lower SLA, but I will point out that when we talk about SLA, we talk about the infrastructure, OS, application, and software. So we talk about here the presentation tier, used for user interactions and interface, covered, of course, by an application load balancer for TLS termination. The application tier for the core business logic and application processing. Executes all of the ERP transactions, including things like order management, HR, and finance. And a database tier, centralized storage for all enterprise data, running on HANA, of course. what we tend to recommend for production, a multi-AZ architecture. This is covered, of course, with automated failover using OS-based clustering techniques, and an SLA coverage is provided with an RTO and RPO commitment. I think it's very important to point out that with AWS, the AZs are a meaningful distance apart. This is a pattern that a lot of customers use and are happy with. Of course, some want more. It's a theme which you'll find today. So here we have production with DR, multi-regional strategy. It comes with all of the benefits of a multi-AZ deployment with, of course, the multi-regional extra. We, of course, provide SLA coverage, including RPO and RTO on top for that. So just to touch a little bit from our point of view about the main benefits, it's a little bit of what you've heard before, but I think really important just to drive that point home is the CPU and I/O performance increases. So especially on the Generation 1 U series, as soon as you went up the terabyte, basically you could run a bit short on the CPU side. And I think I/O, especially with regards to HANA start, backup, and what really adds something to it with NSE, with HANA native storage extensions, the I/O could frequently be at its limits. And finally, and again, Arnie called this out, is the usage of ENA Express. So I have a customer use case I'll talk about in a minute where we touch on this. So how do we use the high memory deployments? Well, of course, we have extensive global deployments for it. We collaborate with our counterparts in AWS to place hardware wherever it's required. Most importantly, we have preview access and early engagement on all new hardware. So we basically aim for Rise ready on day one. And so by extension, the U7 INH we already have, we already tried it, we already tested it, we're already happy with it, and customers can have it. So then furthermore, the Nitro system obviously provides a consistent experience. In theory, it would be possible to jump from something like an R5 to a U7i. Of course, that would be unusual, but the key point is that it is possible. And the fact is that the APIs are consistent no matter what you do there. So this is an interesting topic, bare metal versus VM. 2018, when the U series was first introduced, they were only introduced on bare metal. It was actually a little bit later that the VMs came out. And one thing which is particular about them is the start and stop can be a little bit slow on the bare metals. And it's also worth pointing out that management of dedicated host reservations, DHRs, this is in AWS parlance, a lot of undifferentiated heavy lifting. There's a lot of things you have to consider there. If a health alarm is triggered, relating to a degraded instance, then you also need to remember that when you stop the instance, you're changing the host that it's getting launched into. And they're also outside of, let's say, some of the regular financial discounting processes, such as instance savings plans. So therefore, we recommend absolutely virtual machines. They come with nearly identical performance, and all financial processes that you might have work as usual. And in fact, we are converting bare metal into VMs. In fact, I think we only have around a dozen left. And crucially, if you do also want to do that, you simply need to stop the instance, change the instance type to a VM, modify the placement settings, and start it. It is as simple as that. Touching on block storage, GP3, excellent price performance. It actually answers the demands of our customers to a high 90-something% level. IO2 performance, however, is much better or even better. And it also crucially delivers a lower latency. Something else that's worth pointing out about the IO2 is the much superior AFR, or annual failure rate. So it has a 5 nines level durability. I will point out that whilst the first generation U series benefit from the lower latency of IO2, that if you are doing backups and you are using NSE extensively, you will see the benefits of the latency, which does help with things. However, you will likely just move the bottleneck somewhere else. Yeah, so the 38 gigabit of storage backend on a U instance Gen 1 might just be the next bottleneck you hit. Much improved, of course, with the U7i. And crucially, the GP3 to IO2, this is not a one-way street. This is something that our customers can and do ask to be upgraded from one to the other. Of course, it's completely online with no disruption whatsoever. So just to add some more color to that about our own transition here, so in case you also have a lot of GP2 volumes out there and you're wondering about whether you should upgrade. So we actually started switching to GP3 about 2 years ago now, and all new deployments went onto GP3. We then developed a storage design to accommodate what our existing server infrastructure, or what all the existing deployments we're using, and how to get that to the new design. And the changes, of course, were done online, and I think the most important thing is that customers saw anything, depending on the server type and the configuration that was applied, they saw anything from a fair bit of improvement to massively improved. You know, so the key thing was that with the GP3 volumes delivering 4x the performance of a GP2, you know, and if you look at the pricing, you can actually deliver substantially improved I/O throughput for more or less the same money. And like I say, since you can change this online, this really is quite a no-brainer. I'll point out that since this picture was created, we actually have now closed that down to about 2% remaining, so about 98% fleet. Building on what Arnie said about on-demand capacity reservations. So compute savings plans, EC2 instance savings plans, and regional reserved instances come with no capacity reservation, so no right to run the machine. They are levers for financial discounting. The only exception to that is a reserved instance with a zonal allocation, and then you actually did get a dedicated machine that you could start. So in-life operation, I would call it, you have a lot of static stability. The servers are generally running. The key thing, though, is that maintenances can and will occur, meaning that at some point, someone will have to stop one. And having a good method of managing on-demand capacity reservations is the way to do it. You create them, the tool which you make or use will create an on-demand capacity reservation for every machine that you run, and then in our case, if a machine is stopped, you can run it again. We run a tail latency, if you like, or a tail time on the capacity reservations of around 3 days. And I just want to point out that during seasonal periods, that's a very good thing to have. Moving on to backup. EBS, always incremental snapshots. We use fast snapshot restore, FSR, heavily. The main reason to do this is it avoids the read-through delays that you get from S3. So restoring a volume from snapshot without using something like FSR to pre-warm it will deliver an extremely poor experience on opening the database. We also use snapshot lock for immutability, so it stops people deleting, modifying the snapshots. In fact, SAP were used as a case study for this, and if you Google for snapshot lock, you should find it. And backint. Obviously, S3 with the famous 11.9's durability, low $gigabyte price, we use the backint solution from AWS extensively here. And again, a bit like the snapshot lock, there is S3 object lock as well, which we use, again, to provide immutability from deletion or modification. So I want to touch on the a couple of things that you can also run on top of your RISE with SAP or indeed other SAP system is the AWS SDK, which makes it easy for ABAP developers to extend and transform SAP-based business processes by harnessing AWS services using the ABAP language. It fills a gap between the ABAP builder community and AWS services. Basically, a lot of customers already today are using it in order to reach things like S3. And I would be remiss in not pointing out that also services like Bedrock are for sure on their roadmap. There's also now the SDK available for BTP. There's a QR code here. You can go and check that out. And as the name implies, this is the SDK for the SAP BTP ABAP environment, and again, makes it easy to incorporate AWS services into your BTP solutions. Crucially, this allows you to create SAP extensions and standalone applications while keeping your ERP core clean. I just want to build a little bit of color on what we kind of covered today. So we have a couple of case studies just to quickly run over. It's the same customer, different scenarios. Both times, constraints were actively being felt in CPU, memory, and I/O, all encroaching on limits. And the first one comes, though, before the public release of U7i, and the second one afterwards. So we have HP Inc.'s primary S4 environment. It was originally built on a 24 terabyte scale-up. It was growing extremely fast. So we established an HP, SAP, and AWS joint task force. And a decision was made to scale out that environment to buy much increased headroom. So this shows the intermediate architecture in order to build that scale out. So the new nodes were then first deployed. And you'll note the fact that there's a 24 terabyte in the midst on each area there on the screen. And this was because this is leader node, which then would receive a full copy of the original database. And as soon as it's done, you can then start with the table distribution. So here you see the final solution, where the leader node is then set to 12 terabytes to match the worker nodes. The scale-out benefits were clear, significant increase in compute and memory availability, kind of 3xing it. It spreads the I/O over more servers. It distributes transactional workloads, and it allows parallel processing of analytics workloads. The main consideration is something we pointed to before. It's the cluster placement group. So it's critical for optimal performance before U7i. I want to really point out here that this was it was in a good region, Oregon, but it came with the off-the-shelf availability and really shows the flexibility also of RISE. And the second one, this was their primary BW environment, which was built on 18 terabyte, Gen 1. And it's also growing extremely fast, and it was constrained, again, RAM, CPU, I/O. It's a bit of a theme. In this particular case, what made it even worse was the customer uses AARE, active read enabled. And this allows them to run reports from the HA node, as well as, obviously, it's also having to deal with the commitment of new transactions there. So we decided to immediately upgrade to U7i 24 terabyte. It was a very elaborate migration strategy. There was a shutdown, an instance change, and then we started it. I did want to tell you there was a huge story here, but that's really it. This is as simple as it was, and really drives home the point also brought up by my AWS colleagues. So it's a real-world demonstration of improvements between Cascade Lake powered Gen 1 and the Sapphire Rapids-based U7i, and certainly demonstrates the flexibility and benefits of RISE on AWS. And with that, I'll hand back to Vikas, who's just going to wrap things up for us. Thank you.
Thanks a lot, Dave. So I think just to bring this home, we heard from our partner here on how we collaborate really well from the AWS standpoint and SAP to give you the desired experience that is so much needed for this mission-critical SAP HANA workload. To continue your journey, I think you can schedule your complimentary rise with SAP on AWS Discovery Workshop. There are other sessions also talking about SAP on AWS. Some of them are already in past, but most of them would be available on YouTube video channels. Highly encourage you to watch that. With that, I would like to bring a closer to this session. We'll be standing here. If you have any questions, you can come back and ask us that question. Thank you.